Hello, ladies and gentlemen, and welcome back. Root Beer here with question number 23 on our 2010 Pascal. The product of n consecutive four-digit positive integers is divisible by 2010 squared. What is the least possible value of n? Smallest possible value of n, and we want four-digit positive numbers. So I couldn't just say n is 1 and the one number I'm working with is 2010 squared, because that's probably going to be 8 digits. And that's wrong. We want four-digit positive integers. Okay. Well, if I know something is going to be divisible by the product of my integers, then I really should start looking at prime factors. So what are the prime factors? What does 2010 turn into? Well, divide by 2, we get 1005. Divide by a 5, and you'll get 201. You can divide that by 3, and you will get 67, and 67 is prime. So we get 2 times 5 times 3 times 67. Really, 67 is... So 67 here is going to be a bit of a problem, because I have sort of two options. If I look at numbers that I'm multiplying together, a, and then, let's not call it b, let's call it a plus 1. So a times a plus 1 times a plus 2 times a plus 3, and I just keep going all the way up to a plus n. Well, there. Now, this is a product of n numbers. Okay. And if I want 2010 to divide that, I need, or 2010 squared, I need 2 factors of 2, 2 factors of 5, 2 factors of 3, and 2 factors of 67. Okay? But I can't get factors of 67. I can get one of them just fine, just correctly choose A so that one of these numbers in here is a multiple of 67. But I either get 2 different multiples of 67 to get 2 factors, which means that these numbers are going to have to be a distance 67 apart, which means n has to be at least 68. And you'll notice that none of these answers are 68. Either that or one of these numbers in here has to have a factor of 67 squared. So that's a good starting point. So what is 67 squared? It's going to be 4,489. So if one of these numbers, one of my four-digit numbers is a multiple of 67 squared, it could be this one. Maybe we can multiply by 2. Or it could be 8976. But as soon as I move on to a multiple of 3, I'm 13, 4, 6, 7, and that's 5-digit. That's too much. So we either use 4489, or we use, I just had it, 4489 times 2, 8978. Okay. So this one would just give me 67 squared. This gives me a 2 as well. And so that would knock off a 2 off the list that I need to work with. Okay. Now the 2's aren't going to be a problem. They're really not, because just getting some even numbers will get you the multiples of 2 that you need. Now, I'm worrying about the next biggest factor, which is 5 squared. So I could have 2 different multiples of 5. You'll notice 4490, the number right after 4489, has a multiple of 5, but it's only got one multiple of 5. So if I want another, I've got to, by the same reasoning, go at least 5 terms away. So I've got to have at least 6 in my n. And now we could do something like 4489. We could have 4490. We could go down to 4485. And we'd need the numbers in the middle there. But, so 4486, 4487, and 4488. So that certainly gets me my 2 factors of 5. I've got my factors of 67. And it only took 6 numbers. And There's a multiple of 2. There's a multiple of 2. So I've got all my factors of 2. Do I have all my factors of 3? Well, 4490 and 4489 aren't multiples of 3, but 4488 is indeed a multiple of 3. And so is 4485. So, yeah, this works, and n would be 6 in this case. Is that the best we can do with 4489? Before I move on to consider 8978, is this the best I could do? Well, I need multiples of 5. And if I'm not going to go to 4489, then I'd have to go down to 4485 and go even further to 4480. Not good. Could I go from 4489 past 4490 up to 4495? Sure. But I'm going to have 7 numbers in there. 6 is better than 7. Okay. So 6 is the number to beat. Can I do it with 8978? Also, if we take a look at our multiple choice answers, 6 is the second lowest. The only possibility is maybe we can do this with 5. Maybe. But certainly we've narrowed it down to 2 possibilities, D or A, and that's worthy of a guess if we run out of time. And that's something to think about as we do Part C questions. Now, I noticed that 8978 is really close to 8975, and because it ends in a 75, it's going to be a multiple of 25. So that's really attractive there. So 8975, I'd have to fill in the numbers between. But this has a multiple of 2. It's got two 67s. This has 2 5s. So that's my 25 there. Well, let's say 5 squared. Here's another factor of 2, but okay, now I just need my multiples of 3. I need 2 factors of 3. Now, one of them in here will be a multiple of 3. I'm not entirely sure which one. 8977, does that divide by 3? It does not, so it's got to be 8976. Yeah. So that's a multiple of 3. And when I divide it by 3, I get 2992, which is not another multiple of 3. And of course, we shouldn't expect it, because with only 4 4-digit numbers, if this worked out, then I'd have n is 4, and that wasn't even an option. And turns out this does only give me 1 factor of 3. But if I go to 8979, that is also a multiple of 3. Just double check on my calculator. And so that's where my remaining factor of 3 is, and now I've got n is 5. So A is the answer. It does work out there. All right. So that's question number 23. Up next will be our second last question, the penultimate question of the contest, and that will be question 24. Feel free to give it a try before you watch, and have yourself a wonderful day.